right, perfect. So I'm going to go ahead and get started. I am Claire Bartell. I'm a sales engineer here. I've been with the company for about 8 years, so lots of talking to customers, lots of hearing about their applications and the exciting stuff that they're working on. So the topic of today's talk will be maximizing your printer ROI, applications from every stage, from prototype to production. So we'll hit on a number of applications and ways that you could use your printer. Maybe you're already doing some of these. Maybe you could pick up some ideas from today. That's kind of our goal. So in terms of agenda here, we'll talk about rapid prototyping and boosting your return there. Talk about expanding your projects using the hardware that you already have. Maybe that means getting new hardware, and then rapid tooling applications, as well as some key takeaways. So to start off, what do you do when you have kind of a large product that you're making and you want to make sure that you're cutting the right tooling? I'll start out with a customer story from Ford that we just released, and I think this is a great example because they're using 3D printing to prototype all of their kind of exterior, internal components, and they're able to kind of use 3D printing to get shorter time on parts, design flexibility, kind of streamline that product development, and make sure that they are not making tooling and then realizing they'd like to make a change later. So this is a project that they did at the Ford Rapid Technology Center in Cologne, and they used Formlabs machines on the new EV Explorer. And another cool thing that they did is use the 3D printed mold to make parts out of end-use plastic. So sometimes the 3D printed material is enough, and sometimes you really need to see what would it be like if it were injection molded. So they used that here. If you'd like to check out that customer story, you can actually scan that QR code and take a look at that. But basically, we're going to look at a couple other applications here, and hopefully some of them are exciting to you, and you'd like to expand and do fun things with your printer. So the first one is silicone molding. So this one I've seen people talk about it today. The customer story in this image is a crayon company called Tinta Crayons. They use silicone molds with 3D printed kind of positive molds to make custom beeswax crayons, and they like it because they can make whimsical designs. The printers allow design flexibility, quick turnaround times, and smooth parts. So this is something that you maybe could do with an FDM filament printer, but it's not going to give you that kind of nice surface finish of an SLA type of application. And not only can you use silicone to kind of mold on top of parts, you can also mold parts within silicone. So this is an overmolding application here. Dame Products uses these kind of molds on the outside to silicone mold hardware on the inside of their products. And I think this is a telling quote here. They say they couldn't do their job without 3D printing, and they're not sure that Dame would exist without being able to print their prototypes. That goes for products like these, and also things like this. So this is actually an air tag within a tag for a dog collar. So you could track your dog that way. And silicone overmolds are good for different durometers of silicone, more color options, and also medical grade materials. So we have a resin that is a silicone kind of resin, but if you want different options, you can get that by using molding. You can also use compressive molding. So this is an application from OXO. They actually do kind of a 2-part putty and then put it into a clear mold. This is good for kind of low heat applications, and they use that to prototype gaskets on some of their shakers. That's a cocktail shaker right there. And it's nice because they can do multiple iterations, kind of change things really quickly, get those parts really quickly, and you can kind of print things, test them, go back and print, and it's a good way to get kind of different mechanical properties than you would from just necessarily, printing a part. And one last kind of story here in this section is from TU Berlin. So they are a Formula student racing team. They have about 80 to 90 people that will build cars in kind of a Formula style and race them. So the part that you see in this picture is a carbon fiber layup on a 3D printed part. And the alternative to kind of making this out of 3D printing is actually to CNC mill this out of aluminum. And that would take kind of a long time, requires specialized tools. They would have actually had to send this out. But this is a good way to get different mechanical properties on your parts. So if we look at this steering wheel right here. This is the part where they actually saved kind of $600 and 4 to 6 weeks by doing this kind of layup composite molding technique. And in terms of all these applications, it's kind of not necessarily that you will it's kind of material costs you're saving. Often you are saving material costs, but it's also kind of the time and the business impact of what having this new technology is. So if you get things faster, you can produce different products, you can kind of iterate faster, and then in the kind of end of this presentation, we'll talk about some end-use 3D printing parts as well. So one other way that you can get kind of awesome, maybe non-3D printing resin material properties is by kind of using hybrid technologies. So we'll talk a little bit about electroplating. Here is a graph of kind of the strength and tensile modulus of some materials. So you'll see we have 3D printing over on our left-hand side. We have kind of metal alloys on the top right. And I always get this question when I go to trade shows. They come up to the booth and they say, can you print metal? And right now, still no. But you'll see that gap there, and what we are able to do is fill that with coating our resins with metal materials. So we send these out to a plater and kind of tested them again, and we saw that it's a good way to bridge the gap between just 3D printing parts and then having kind of the metal part. So that opens up new options for those parts. You're not necessarily going to have to machine something out of metal until maybe the final iteration or something like that. So that opens up kind of 3 different main categories of how electroplating is going to change your parts. One is mechanical, so you'll see this kind of almost latticed cube here. That's actually about a 2-inch by 2-inch square. And what we do at trade shows is we put that out, and stand on it. So you'll see the 3D printed version there. That'll break if you stand on it. And that electroplated version will not break. So we've put kind of hundreds of pounds on that. We've handed people heavy things so they stood on it, and it still survived, which is really cool. You can also do kind of electrical and shielding applications. So we've been plating some of these. That's a copper plate. We have some white papers online for you to check out if you're interested in that. And then kind of not on the mechanical or electrical side, you can just plate things so that they look cool. So if you're making props or you're designing products, electroplating is a good way to get kind of a really unique surface finish on the parts that you have. And it's a kind of good segue into generally how we're prototyping and kind of where we are in mass production. So 3D printing, I think, is very common in the prototyping space, is accepted by the industry as a good tool. When you're not making many parts, maybe you're doing kind of concept prototypes, first prototypes, it's a really good fit there. I think it's kind of matured there. And then if we look at the mass production side of things, I think it's not as mature there. It's not as accepted by industries as a good solution for making mass production parts. Some of that is materials based, I've heard some talk about that in other talks and in workshops that we've done today, and they're definitely right. So what we are good at today is this middle section here. So similarly to the electroplating, plating parts is a good way to bridge the gap. We are able to bridge this gap with 3D printed tooling. And that means that you can do functional prototypes, maybe of end-use materials. You can do kind of pilot prototypes. We'll take a look at a story where they use 3D printed molds to do pilot studies. And then you can also do kind of limited run production or maybe customized production that way as well. So rapid tooling, as we define it, is combining 3D printed tools with traditional manufacturing processes. It enhances production by improving its flexibility, agility, scalability, and cost efficiency. And as a result, you can use 3D printing to meet business needs quickly, make affordable, low-volume production feasible for your in-house applications. And a couple of good use cases for this. I'll read at the bottom too. So functional prototypes using the final material. This is exactly what Ford was doing. So if you just need a couple parts that are maybe a thermoplastic, but you have resin printing, you can make molds and injection mold it. You can also use it to make kind of pilot production, so multiple parts, kind of try them out in your production line, see if they fit, see if they can be assembled, and then also make end-use parts. So that last one is a max strap. Maybe you have parts that aren't manufactured anymore. You can make molds to manufacture those. So the next customer story that I'll talk about is a Unilever and Stereoplast Global Services story. And they are kind of a manufacturer in the fast-moving consumer goods category. So that's kind of soap, shampoo, your essentials that you'd buy in kind of a drugstore. And in that industry, it's important to be competitive because if you kind of aren't and you're not innovative and you're not adapting your product strategy, you can lose out on a lot of business. So they use some 3D printed molds to prototype this bottle for dish soap. And it's important to innovate the packaging because the design of the bottle can have an effect on the customer perception of the product inside. So it's nice to be able to put them out for pilot prototypes, get feedback, have people use them in their sink, use the soap, and make sure that it doesn't fall out of their hands and the bottle looks good. So here's some pictures of that mold being assembled and used in their blow molder. So the process they're using here, they're using this mold to kind of inflate plastic preforms and make bottles that way. So kind of cool, we had some injection molding and now we're able to have a blow molding story as well. There's some more pictures of it being assembled. So it's really being kind of put into that traditional manufacturing space and to that traditional manufacturing process. And you'll see it's nice for the 3D printed molds to have kind of a metal outside just to make sure they're pretty strong by themselves, but good to shore them up. And this process is important because they can test the material usage, the aesthetics, kind of safety and sustainability features. So they're doing some testing here, making sure everything's kind of the right weight, that it looks good, and that those products, once they cut the mold, are going to meet all the properties that they're looking for. There's another picture of that mold there. So that's actually the final mold. And if they're just making this mold from kind of computer to CNCing this, it can take months just because their design process, they have to kind of check everything and be really diligent. And what that means for ROI is that by 3D printing molds and doing pilot tests that way, you can save a ton of time and a ton of money. So if we look here, comparing the kind of machined metal mold to the 3D printed version, they did that in 2 weeks, whereas they were machining a mold in kind of 6 to 8 weeks. In terms of costs here, it is a significant cost reduction. So when they did this analysis, it was about 80 to 90% less cost. And these numbers are run on a Form 3L. So Form 4L is a little bit faster. Maybe it's a little less than 2 weeks, but cost may be about the same. And we see the same thing not only for blow molding, but also for injection molding. So if we look at this graph here, we have the same situation where maybe the 3D printed prototype is fairly cheap, maybe $5, $10 in material cost. But then if we were to go cut kind of a traditional manufacturing injection mold, that's up to $100,000 just to get that kind of made on a CNC machine out of metal. And we can fill in this gap in the middle with 3D printing. So the molds are fairly accessible. They work well for low-run production, and they let you test your products and your mold itself before you kind of cut a final mold. So looking at kind of what changes when you're doing a 3D printed mold versus a metal mold, the answer is not very much. So you still have to include draft angles, kind of pay attention to how your gate is letting resin in, avoiding kind of small features and making sure that things won't break as you're injecting plastic inside. This is kind of an example of a mold here. If you want more details on that mold and kind of designing molds in general, you can scan that QR code. And this was made for mass straps that we saw earlier. And in terms of kind of how these are printed, generally we want flat on the platform. We do most of these in about 50 microns in a rigid 10K, so that is a glass-filled resin. And that is a great material because its heat deflection is 218C, so that's enough to stand up to most plastics. And you'll see that most of these are in a mold frame. That's just a good, easy way to, A, get them into the injection molding machines, but also kind of make sure that they are getting enough kind of mechanical support on the back end if you're really pressing them together and injecting plastic inside. So in terms of kind of resins or kind of regular traditional resins, thermoplastics, we can do a number of those, pretty much all the common injection materials you can put into a 3D printed mold. In terms of injection temperature, we cut it at about 250 C, so everything that injects lower than 250 C, you get more kind of shots out of that mold, so that's maybe hundreds of parts. Anything that is an injection temperature higher than 250 C, you may get fewer, and that's just because the resin does kind of start to combust in the presence of oxygen around that temperature, so that's the one to keep in mind. Haven't tested kind of really high temperatures, but your kind of TPE, polypropylene, polyethylene, those all do really well in 3D printed molds. So if you're looking for kind of specific numbers, we have this white paper you can check out. It's basically all the process conditions that we've tested so far. So how long that cycle time was, what injection temperature it was, what we printed the mold out of, and some other good details there. So that's a good working place if you have maybe an injection molding machine, you have a printer, and you want to try this out. Now to show you a couple instances where this was used. Multiplus is a company in Shenzhen, and they have kind of sort of 250 clients per year. They're a micro injection molding workshop house. This is a mold that they made. I think it's a cool example because it actually has the ejector pins that push your part out after it's molded. And they were able to get hundreds of these electronic housings out of these molds. And it's a good thing to point out, too, that even if you need multiple molds because maybe the mold fails after 100 parts, you can just print another one. So this part was less than $500 in material. This is the kind of build platform of Form 3. So you could, for size. And they were injecting this part out of polypropylene, ABS, polycarbonate, some other materials as well. They were getting pretty good cycle times out of this. So this is a cool kind of example. I've gotten the question whether you can do mold cores actually fairly recently. So this is a nice example for both kind of the AB side of the mold and a core in the center. So this is a threaded bottle cap that they wanted to test in its final plastic form. So they got kind of hundreds of cycles off of this one as well. This is from Novus Applications, which is an engineering and design consulting firm. And here's kind of a good schematic of those threads in there. And where it looks printed. So this is also less than $500 in material. Compare that to maybe that much or multiples of that if they were to send out a mold. And kind of one note about molds too is that you may need to sand down those surfaces, so you can kind of add a little bit of extra, sand them down, make sure they're flat, and they work really well. And the kind of last molding we'll talk about today is thermoforming and vacuum molding. So this is a pretty cool opportunity to do kind of end-use parts and use them to form sheets of plastic. So if you have a dental liner, a lot of them are formed this way. And another kind of use case that we've had in terms of user stories is actually for bath bombs. So Lush bath bombs used 3D printers to print the positive molds and then mold on top. And they noted kind of a cool benefit, which is that they don't have to send their parts out to third parties, and they like to keep all of their kind of internal IP private. So it's kind of a qualitative benefit of 3D printing, but I think it's still cool that that is something that they really appreciate, so that they don't have to share any of their designs with anybody else. And this also is a good benefit for kind of short runs of parts, custom parts, and prototyping designs. And then we can go into kind of end-use applications. So if you have a Formlabs product, there's a good chance that there is a 3D printed part on it. You'll see a number of examples here. We have the kind of turntable coupler in the Form Cure is actually a fused printed part. The resin pumping system has a number of fused printed parts. And both the 4 and 4L have tool caddies that are fused printed parts. So we definitely practice what we preach here. And we both prototype with these 3D printed materials and put them into production contexts. And the customers are doing the same thing. So this is Expector. They make kind of game cameras that attach to the outside of cars because their sensors couldn't get through a car window. And they actually use both resin and SLS printed parts for their products, which means that they're able to kind of flexibly incorporate customer feedback, able to put in a lot of design complexity that they would have to kind of tool difficult molds to get. And they can do things like lattices, intricate shapes, organic features. They kind of have full control over their product. So I think this quote is cool because they kind of think about their product like a living product. They can incorporate feedback, whether it's kind of features people want or they get a bug request, they can fix that and change their design, print out new products. And one other note about kind of printing kind of full scale, maybe production parts, is that we do have bulk discounts. So if this is something that you're interested in doing, you want to print tons and tons and tons of SLS parts or tons and tons of resin parts, often there are price breaks available. So chat with any of the sales reps here, kind of talk to us on the website. We're happy to discuss both the applications in your project and pricing that would make it feasible. So wrapping things up, some key takeaways. I hear all the time, I get on kind of calls with customers and they have tons of ideas about what they want to focus on. I think what's the best way maybe to get, if you're looking to get someone to approve a printer, is just to focus on one project and then treat the others as bonuses for a little bit, just because it's sometimes easier to run numbers with one thing. Even if you're excited about a lot of things, just kind of focus on one. And that you should be kind of thinking of creative ideas to use your printer, and you can get better outcomes from prototyping to production by using 3D printing, whether that's kind of prototyping parts or using them for molds. And yeah, again, if you have interest in producing a lot of parts, talk to us about discounts. We can definitely give you those. Awesome. So I think the resources in the room today, if you're here, talk to each other about your ideas. If you're online, there is a forum as well as the chat in the YouTube or the video there. So put your ideas there, put them in the forum, and any formling here is happy to talk too. Thank you.